Hello everyone, welcome to my channel IndiaGATE. This is Nandani Sharma, and in this session of the linear algebra, we talk about the properties of the eigenvalue, eigenvector and important questions with related gate and other competitive exams. So let's get started. Now here, properties of eigenvalue is defined as a matrix is given like A minus lambda I x equal to 0, that is your characteristics equation. Now here basis of this equation we got here Bx equal to 0 for the homogeneous linear equation, okay, or so we say that this is mod or determinant of the B is equal to 0, and the equation will be become A minus lambda I equal to 0 for the non-trivial solutions. Now come to the some solutions like and properties of the matrix A n into n. If a matrix n into n having the eigenvalues like lambda 1, lambda 2, lambda n times, then the properties are: first, determinant of A is equal to product of the all eigenvalues, means determinant of A is equal to lambda 1 into lambda 2 into till n times, okay. Here trace of A is equal to summation of all eigenvalues, means A11 plus A22 plus A33 till ANN is equal to eigenvalue 1 plus eigenvalue 2 plus till eigenvalue n times, okay. Now next properties is, if a matrix having the eigenvalues like lambda 1, lambda 2 and lambda n times, then function of A is equal to function of lambda 1 into lambda 2 into lambda n times, okay. Now we say that if a matrix is defined as K into A, then the matrix is also, we say that is the value is equal to Ka is equal to K lambda 1 into K lambda 2 or K lambda n times, okay. Means Ka is also replaced with K lambda, okay. And also we say that matrix power of K, it is also equal to the eigenvalues power of K. For example, if the values of the A square plus 3A plus I plus lambda is asked by the examiner, then what the short trick to find the answer of this question? So firstly we found the eigenvalues of the given matrix, then just put the eigenvalues in place of the A and we got the answer in just few seconds, okay. We know about that in the examination we have no more time to solve the question and go to the standard procedure, so we come to the what this type of the properties and short tricks to solve the question in just few seconds, okay. Now come to the next, with perspective of triangular matrix. We know that triangular matrix is upper triangular matrix or lower triangular matrix. Then in the case the diagonal elements are eigenvalue, okay. This is most important point for you. Now come to the next. Here in the case of the symmetric matrix, the eigenvalues are purely real and eigenvalues are orthogonal, okay. If A having the eigenvalues lambda I, then eigenvector is xi. If the function of A is equal to the function of lambda I, then in the case of the eigenvector is not going to be changed, it remaining same, okay. And the next important formula for you, length of the matrix vector is equal to under root summation of A square in. Now this is the most important formula for finding the length of the matrix vector. Now come to the next important properties with related matrix and into n. We know about that trace of the matrix and diagonal of the matrix is equal to the eigenvalues. Okay, so here summation of eigenvalues is equal to summation of aii, that is your trace of the matrix, and here product of the eigenvalue is equal to your determinant, which is already we discussed. Now here most important property is that if determinant equal to 0, then the matrix will be singular, and here rank of the matrix is less than number of unknowns. Okay, here n is your number of unknowns variable, and it is your linear dependent matrix and non-dependent matrix. So we say that at least one of the eigenvalue is 0, then we say that the matrix and determinant is your 0, and this is called your singular matrix. Now next important point with related this defined as if determinant is not equal to 0, then the matrix is said to be non-singular matrix, and here rank of the matrix is equal to the number of variables, unknown variables, and it is called linear independent and independent variable where the eigenvalue is non-zero. Okay, and we know that the most important properties is given like A and A transpose having the same eigenvalues. Yes, because determinant is same, so eigenvalue is also same. Next is your triangular matrix based. So we know that triangular matrix by diagonals are the eigenvalues. Okay, now come to the next matrix based eigenvalue. So here matrix, Hermitian matrix or symmetric matrix defined. Okay, so in the Hermitian matrix, it is the eigenvalues are purely real. Okay, and vectors are orthogonal. Now in the case of the orthogonal, we know that the transpose of matrix is equal to inverse of matrix. Now next is your skew Hermitian matrix. So in the case, the eigenvalue are purely imaginary or 0. Okay, so in the case of when we found the skew Hermitian matrix, so the determinant and eigenvalue is purely 0, 1 and imaginary, like a plus bi or a minus bi set. Okay, now come to the next, that is your unitary and orthogonal matrix. So in the case of these two matrix, the eigenvalues is always equal to 1. Okay, so we say that here the eigenvalue is may be your plus minus 1. Now eigenvalue of the function a are the equal to the function of lambdas, but here vector eigenvector is same. Yes, we already discussed about it, and here it is already same for all this. Okay, now come to the next important terms and key points. If we found the value of the a square plus 2a and eigenvalue is already given, so we just put the eigenvalue in the place of the a and found the answer of this equation. Okay, and we know that adjacent of a is equal to mod a inverse. Okay, means a inverse is equal to what? That is adjoint of a upon mod a. So this is the formula for the inverse, which is basically just a using of the all the terms. Now in other way we say that if a inverse is also equal to the 1 upon a. Okay, so 1 upon a always when they giving the terms of eigenvalues, so 1 upon lambda I and 1 upon eigenvalues is your sorted terms. Okay, next is your idempotent matrix. So in the case of the idempotent matrix, a square is equal to a, so we easily say that the lambdas and eigenvalues are 0 and 1 in the case of idempotent matrix. Now come to the some method which is used. So there are various methods to use for here, but here we use only 4 methods First is your standard method, which is not used by us. Why? Because it takes long time, and in the examination we have no more time to solve it through standard method. So we use the other method like method 2, 3 and 4. So get the quick answer. Now here characteristic equation is given like that. In the case of the matrix is 3 by 3, then the characteristic equation is given like lambda cube minus s1 lambda square plus s2 lambda minus determinant equal to 0, where mod a is your what? Determinant, and the s1 is the sum of the element, that is your trace of the curve, that is a11, a22, a33, that is sum of the diagonal elements, and s2 is your sum of the mirror of the diagonal element, that is your mod element a11 plus a22, a33. Now third method is defined as the properties, which is already we discussed that the summation of the diagonal is equal to summation of all eigenvalues, and fourth method is based on the determinant is equal to the product of the matrices. Okay, product of the our eigenvalues, so which is defined like as. Okay, now come to the another most important points. Any matrix like 3:3 have the non-zero eigenvalues, then the range of the matrix must be equal to 3. Okay, next is infinity solution is called your eigenvector. Okay, when we got the infinity solution, then here is eigenvector is used when the eigenvector is given and we found the eigenvalues. Okay, the term is like this, then the common term of this sides is the your eigenvalue. Okay, this point is considered, it is very most important. Okay, now come to the next here. The given matrix like 0, 0, 0 is never be an eigenvector. Instead, at least one non-zero eigenvector is exist. Eigenvector means non-zero solution. For rank 2, constant k value is taken from the solving the eigenvectors. Okay. Now here coming to the questions, that is most important questions. Here the eigenvalues of A, that is 1, 2 in first row, 4, 3 in second row, are minus 5 and minus 1. Then eigenvalues of the minus 2A plus 3I. Okay, where I is your 2:2 identity matrix. So there are 4 options. Option A minus 7 and 5, option B 7 minus 5, option C 7 minus 5, and option D 1/7, 1/5. Okay, now come to the solution. So here two eigenvalues is given, like lambda 1 is 5 and lambda 2 is your minus 1. Now using of the Cayley-Hamilton theorem, then we know that A is replaced with lambda. Now when we putting the values in the first equation which is given in the question, then we got the values of the given, like when we putting the and substituting the lambda 1 values, that is eigenvalue 1 in the given equation, we get here minus 7, and when we putting minus 1 we get 5 in the given equation. Now option A is correct, means our right answer is minus 7 and 5. Now here second method is also given, which is very long. Now after we using of this method, so we know that here using of putting the values and getting the characteristic equation and then found the all the values, which is very long. So don't waste your time, come to the solve trick. Okay, now next question is given like that, the value of x for which matrix. So here matrix is given like A equal to 3, 2, 4 in first row, 9, 7, 13 in second row, minus 6, minus 4 and minus 9 plus x in the third row. Okay, has 0 as the eigenvalue is, means here eigenvalue, one eigenvalue is 0, means we easily say that the determinant of the matrix is 0. Why? Because any of the eigenvalue is 0, then the determinant is equal to the product of eigenvalues, which is already given. Okay, now so it is equal to 0. Now when we putting the values is equal to 0, and after finding the determinant we get the lot of time process. Okay, a long process, so this is going to be long. Now come to the second method and short method for solve this question. So now we considering this matrix, we get here row 1 having the elements 3 2 4 and row 3 having the elements minus 6 4 minus 4 minus 3 plus x. So the first row is multiplication of the third row is the multiplication of the first row minus 2 times. Okay, so after the comparing this row r1 and r3, so we get here the value of the x equal to 1. Okay, now come to the next question. So next question is defined that the eigenvalue of the matrix are 0 1 in first row, minus 1 0 in second row, and here options are I and minus I, option B 0 and 1, option C 1 and minus I, option D 0 and minus 1. Now we know that the summation of diagonally is equal to the summation of lambdas. Okay, that is your eigenvalues. So here diagonal is 0 plus 0, that is your 0. Now only one equation is satisfied this equation, that is your option A. So option A satisfied the first equation, that is diagonal element is equal to 0. So when we putting the values, we get here 0 in the case of the option A, but in the other case we don't found the answer. And also we say that the determinant is equal to product of the matrices, and when we found the here determinant, we got here plus 1. Okay, here determinant is what? Determinant is plus 1, and after the putting the value lambdas like I and minus I, we get here plus 1. So option A is your correct answer. Now come to the next question. Consider the following matrix. So this matrix is given like that, and here R equal to 1 2 4 8 in first row, 1 3 9 27 in second row, 1 4 16 64 in third row, and 1 5 25 125 in fourth row. The absolute value of the product of the eigenvalue of the R is what? So this is asked, and this question is compared into the gate of which is most important for us, and we know that the determinant of the matrix is equal to product of the all lambdas, that is like this. But this method is very long process and it taking the lot of time. Now come to the next method which is defined here. So the matrix is given like this type of the matrix format, that is known as the van der Mode matrix. Okay, and after the simplify the matrix, we get here this type of the matrix. Okay, so for the van der Mode matrix, the determinant of the matrix is formulating like x minus x2 x1. Here the value of the x1 x2 x3 and x4 is given like this series, and we got it like this. Now we just substituting and just subtracting the all these values in the place of the given elements value in the matrix. So after the executing these formulas like x1 minus x2 into 1 minus x3 into x1 minus x4 into x2 minus x3 into x2 minus x4 into x3 minus x4 means this x1 is subtracted by all the lower element, then x2 is also subtracted by lower element, and x3 is subtracted by lower element. All these are multiplied to each other. After putting these values, we get here the determinant of the r is equal to 12. So this is the short trick to solve this question, which is very easy for us. Now come to the next question. Here next question is defined as eigenvalue of the A is given here. So matrix is given, but eigenvalues are not given. So there are four options: option A, B, C, and D. Now come to the solution of this matrix. So by considering the matrix, we got here the matrix is given like 2 to 4 in first row, 2 minus 1 2 in second row, 4 to 2 in third row. Okay, now here we know that the summation of the diagonal is equal to the summation of the lambdas, that is your minus 3 in the first equation, and we know that the determinant is equal to your product of all matrices, which is 28. Okay, now which equation and which eigenvalues are satisfied these two conditions? If these two conditions is satisfied, which all the condition, then that is the correct option, and C is satisfied these two condition, that is your minus 2, and 7. So this is your correct answer. Yes, why? Because after the producting and determining these two, we get here 28, and after the adding all these, so in this case we also get the 7, means 3. So this is your correct answer. Okay, plus 3 is your sum of the all the lambdas. Now come to the next question here. If eigenvalue of the matrix A is lambda, then the eigenvalue of A square is 4. So we know that using of the Clay-Hamilton theorem, if eigenvalue of the A is lambda, then the value of A square is always lambda square. So lambda square is your correct answer. Now come to the next question. And next important terms, basis of the our question is given. If the matrix is given like in the form of K into A using of the Clay-Hamilton theorem, so we get here it is equal to the K lambda. A to power of K is also equal to the lambda to power of K. A inverse equal to lambda inverse. A adjoint is equal to K dot lambda inverse. Okay, sine A is equal to sine lambda, and we easily say that A square plus 3 A plus I, where I is your A to power of 0, that is your identity matrix. So it is always equal to the lambda square plus 3 lambda plus lambda to power of 0, that is your this equation. Now these are the important terms with related of the eigenvalue and eigenvector, and find the quick value of the given equation. Now next question is given like that: find the eigenvalue lambda in the given system. So system is like given here. Okay, and there are four options: option A, B, C, and D. Now we know that using of the method third and fourth means sum of the eigenvalue is equal to sum of the diagonal, that is your 4 plus 2, that is 6, and product of the eigenvalue is equal to the determinant of the matrix, that is your 8 minus what 3, that is your 5. And now come to the solving these two equations, we get here lambda 1 is equal to 1 and lambda 2 equal to 5. So we easily say that option A is your correct, means the eigenvalues are 1 and 5. Okay. Now this session is the end here. I hope you understand all the properties and questions. Thank you for watching.